Okay, welcome at the second part of lesson 2, the languages part. Let's start with a small repetition. So if we have a language, we have to talk about an alphabet. So the language contains words we can make with the symbols, the letters from the given alphabet. In this case, we have an alphabet with only the symbols, the letters 0 and 1 in there. And there's a prescription for the words we can make in this language. The words have to start with 0, 1 or have a subword 1, 1, 0. So let's see what this means. So all words have to start with 0, 1. So apparently, if I just have 0, 1 and leave it like that, it would be a good word. But I could also do 0, 1 and add it with whatever I like. Because the only thing we really need is to start with 0, 1. Okay, but there's also a second possibility. It can have a subword 1, 1, 0. So somewhere in this word of the language, we have 1, 1, 0. So there could be things in front of it, there could be things after it, anything we like, as long as we can trace this 1, 1, 0 somewhere in this word. So let's see if we can write this in a set notation. So apparently we have two options. That means we will have a union in the middle. One option is we start with 0, 1. And then we can add as much as we like from the alphabet in any combination. So we can choose from 0, 1, 0 times, 1 time, 2 times, 3 times, whatever we like. And then the second part would be we have a subword. So somewhere in the middle there is a subword, and before that subword I can choose whatever I like from the alphabet, also including nothing at all, and I can finish with anything I like from the alphabet. So the complete prescription would be start with 0, 1 and take 0 and 1s as many times as you like, or have the thing 1, 1, 0 in the middle. So or means united with the set representing 1, 1, 0 in the middle, something in front and something in the end, and we don't care what it is. Okay, if we look at languages, then we can describe them in several ways. So we can do this with a set notation. So for instance, you see this language 1 is with a prescription. So we have 1a followed with n b's, and this n could also be 0. So for instance, this language contains of a, or ab, or ab square, etc. And the other one is another notation. So we have a set prescription. It means we can take a, b as many times as we like up front, but we have to finish with ab. So if I don't make a choice at all, I only end with ab. But I could also do 3 a's, 2 b's, and end with ab. So only important thing is that it has an ab at the end of the word. A second way of describing a language could be with the help of a graph. We will do that the next lesson about languages. And we have a third way, but that only applies to regular languages. We can use a regular expression. And basically a regular expression is similar like the set notation. But now we say, okay, if I have this expression, we can make words. If we start with A, continue with B, and then choose as many B's as we like. For instance, no, because there's a star there, but we could also do 2 B's or 3 B's, etc. So the language which is formed with those words is the complete language L1. So it's based on a prescription. Language 2, basically the same thing. We choose from A or B as often as we like. So language L2 contains A or AB or BA or B square or whatever. So I can choose A or B as often as I like. And note there's a special one here. I can also choose nothing at all. So that means that lambda is part of this language as well. And in L1, you cannot have lambda because we definitely have to have AB inside the word. If we look at this regular expression a little closer, then there are some rules to have this regular expression. We can only use a restricted number of symbols, so we can use brackets. We can choose 0 or more. We can have the or we can have the empty words. Combinations with these symbols form a regular expression. So let's see if we can figure this out. So I have a regular expression R, which is A star. What kind of language, what kind of words can we make with it? Okay, so apparently I don't have to choose anything. That means lambda is part of this language. Or I can choose one A, or I can choose two A's, or etc. So apparently the language is lambda and words which contains only A's. Okay, this is a small difference. Now I have a language which starts with an A, minimal one, and then has as many A's as possible. So this is a good word, this is a good word, etc. So note that we cannot have lambda now because we have minimal one A in the word we're using in the language. Okay, if we look at the symbol or, so we can have words which either have an A or as many B's as we like. Let's look at this. So apparently I can have the word with only A, or I can have a word with two B's, or a word with three B's, or a word with no B's at all. So the language would be defined as the word A, lambda, and then words with only B's in there. We can also have a language where we can choose from A or B as often as we like. So, because there is a star around the complete line, we have lambda again, but we can also do A, A, or A, or only B's, whatever. So I can choose any combination of A's and B's as. Okay, this is a funny one. Now we have a language A and, but hopefully you remember that this and is not an allowed thing in a regular expression. So I cannot make a language with this one because the symbol is simply not allowed. If we look at the priority in our regular expression notation, then the star has the highest priority, then concatenation, and then the or. So if we look at this one, A or B star or C, it means that this one has the highest priority. So here, then we have the concatenation, B star with C, and then of course we have the or.